Hello. Yep. So good morning, everyone. We'll start off. I'm your moderator for today, so I will make sure that the time is kept on time and the questions afterwards. So I want to introduce Azu and V. So they both work at Vanderlande, and actually they also met at PyData Eindhoven 2 years ago.
Yes.
So it's a small world after all, and then you can see what that brings you. And I also want to mention that they both like cooking as well, and like pizza, spicy pizza as well. So you can also ask them about that afterwards. Yeah, without further ado, good luck and enjoy the talk.
Okay,
Thank you.
thanks. Well, good morning, everyone. Nice to see all of your fresh faces here. It is a bit early for us as well, so we thought let's kill two birds with one stone and let's get to know the audience a bit while also get a bit energized this morning, right? This is the only thing you have to do is follow the instructions on the screen. It's gonna be easy. Let's see if it works. That's the first talk of today, yeah? And do I have to point somewhere? Let's see. Let's see. Okay. Well, first instruction. While people are coming in, you're already getting put to work. All the data engineers in the room, you're lucky. You can stay seated. If you're a data scientist, can you please stand? Just like us. Nice. Good to see everyone moving. If you are a machine learning engineer, you can also stand up and put your hands up in the air. Okay. And for all the others, let's see. Please also rise and wave to me because I'm not forgetting you. Okay. Very nice to see you. All right, you can stay seated. You can stay seated. Okay. Just one more because this is something I would like to know as well. Within your job function, do you feel like you're more so doing things outside of it? Maybe you're a data scientist that also does some data engineering, or are you really a master of one? So if you feel like you're a jack of all trades, please stand.
No.
Okay, this is overwhelming. Okay, I cannot even see the back. Well, thanks, stay seated. Kind of proves my point because, we are Azu and V. I guess we owe you an introduction as well. We've gotten to know you, now you get to know us. We are both data scientists, and we soon realized that we are not just hired to create some models, to develop them, to optimize them. No, we realized, okay, it is getting quite some value. People are starting to see the value, and now they want more models, and they want it fast. And we're like, okay, wait. We just know how to make the models, and not how to do all of the rest, like creating end-to-end machine learning pipelines. Think of a sound MLOps architecture, do some monitoring, write some unit tests. For us, that was, a bit out of the box, and it was a first. But hey, with our can-do mentality, we did it. And today we'll tell you a bit of our journey. So hopefully if you're in the same boat like us, you'll learn from it. Or, you can relate to the story and I'll tell you that you're not alone and we can have a talk afterwards. So, without further ado, Asu, can you properly introduce yourself now to the audience?
Yes. Thank you. I'm super excited to be here. My name is Azucena, and a little bit of my background. So I have been a data analyst in Bank of Mexico. Oh, thanks. Okay, first time, so... Okay, can you hear me now? Okay, perfect. And then as a data scientist at AB InBev, and now in Vanderlande. And I studied actuarial science for my bachelor's and then master's and ND data science. And a fun fact about me, I love spicy food, I'm the one, and I always have a sauce ready. And what about you, Fee?
Yes, I'm her colleague, also work at Vanderlande for 4 years now. With a background in mathematics and data science, I studied here in Eindhoven. And I also love food, like Martien already introduced us. I love to keep track of all the good restaurant spots in cities. So if you have some nice recommendations, let's talk afterwards as well. So, talking about food, what's on the menu for today?
Yeah, so that's a good question. And as always, in all the data science journeys, we start with some data understanding. So here I want to discuss more about like what we do, the company, and also explain why we are doing so many models. Then we will talk about, okay, so how do we actually make it happen? How do we design for scaling up to many models? Then we will go to some deploying, so how do we actually put it into production? We will talk about how do we keep track of so many models and so many jobs? And finally, yeah, how can we do better? Yeah, and with that, I think we can start with data understanding.
Yes. And before we go to the data understanding, I think it's a little bit important to know what Vanderlande is doing, just to get some context. Who of you have heard from Vanderlande before? I'm not going to let you stand another time. Oh, that's a lot. Okay, well, good to see. Most of you probably know it from the baggage handling systems at the airport. I just want to share with you, I see some nodding, I just want to share with you, we're doing a bit more than that as well. We're making automated logistics systems for other parts of the world, of other domains as well. To give you an example, 2 weeks ago, I got tempted. I bought a new coffee machine. It was Black Friday after all. All I had to do was just to order the coffee machine. I ordered it online, and the next day it was delivered. Well, very nice, happy me. But in between, it already touched 2 Vanderlande systems. The first one being a warehousing system, where the moment that I clicked order and I paid everything, the robot grabbed the coffee machine and it automatically got packaged. And the second machine is being a distribution center, where the package is being sorted and is guided to the correct truck so it can be delivered to my door. So that's already 2 other machines that we're working on as well. And now imagine that one of the conveyor belts in the distribution center breaks. Well, that's gonna be not so happy me the next day, because I'm missing my coffee. But also not just me, maybe the other packages on the conveyor belt as well. The trucks that had to wait for these packages is also delayed, and there are maybe some children waiting for the Sinterklaas presents that are not being delivered on time. Well, that is a big problem, and we are working at Vanderlande to solve that. What we're doing is we are creating some predictive maintenance solutions in order to prevent that this breaks down during very, very high peak times. What we're doing is based on data. We're trying to get some insights to tell the site where things are likely to break or what needs some attention. How do we do that? Well, just to give you a high-level overview, we have a predictive maintenance dashboard, and that dashboard is being used by some people in the company that are both more data savvy but also know a little bit more about the system. We call them the expertise center, and they are receiving alerts from our dashboard whenever something is going wrong. So we detect, for example, conveyor X is not healthy. Well, what can they do? Well, they can dive a little bit deeper in the data and they can then decide, I really think maintenance is needed now. So they will get in touch with the maintenance team on site. And this maintenance team is very close to the system, and they can take a look at what's going wrong with conveyor X. Maybe the conveyor belt is worn out a little bit and they just need to replace it just before it really snaps and breaks during times that it matters. So let's dive a bit deeper into what is happening in such a system, and specifically a warehousing system. That's where I'm going to hand it over to Azucena.
Thanks, V. Yeah, let's see. Before, I want to show the audience a cool video of one of our systems. Okay, so this is a system that we call Adapto, and it is an automated storage and retrieval system. Don't worry if you haven't heard of it before, but the robots that you see roaming around in the racks, those we call shuttles. And their function is to retrieve and to store items in a quick and efficient manner. Okay, so I hope that some of you are thinking, how do you predict a failure in such a complex system? Because we were wondering the same. And well, yeah, I have to tell you something. Failures are rare, but they are costly, as we already mentioned. So we want to prevent them. But how do we do it? So another thing is, okay, so they are rare, which meant for us that we have to do unsupervised learning. Well, let's talk about the data. So these little shuttles, they make movements, and each move we call a drive, and we collect the aggregated driving data from these shuttles. So let's picture it. We have the shuttle, and you can see that it starts moving, so it will have some acceleration, then it stops, some deceleration going on, but it also needs to make sure that it's in the right place to retrieve the item that it needs, so it does some repositioning. So with all of this data, what we try is to use the model to understand the normal behavior of the system. And in that way, when it deviates from the normal, we can send an alert. Okay, but normal behavior can change in this specific context. Why? Well, you already saw the system, and it has many levels. And each of those levels have different size boxes, different weights, even different temperatures. They can get really high. But we also have different types of shuttles. So some of them have like different arms, some of them can like reach deeper, different decks. And even among the same shuttles, some of them have different conditional configurations or initial conditions, so like tighter bearings, for example. So with all of that, we decided, okay, let's represent each shuttle with its own model. But you already saw the system, right? So for that, it meant we needed to manage hundreds of models. Okay, but how do we do that?
Yeah, as I said, I don't know. I mean, I just created a model that worked for one shuttle, and then, well, it became so popular, and the demand rose that, okay, let's try it out, you know? So that's, yeah, if you would do it for one shuttle, how would it look like? Very simple, I think many of you know, but what we did is we create just a feature pipeline that then has a feature table with all the data that Azu just described ready for us, such that we can use it to train a model, an anomaly detection model. And this model we then use to do some inferences so that we can see when it deviates from the normal behavior. Well, easy. So for 100 shuttles, what would that look like times 100? Well, I don't know. I don't think that's a good approach, but we tried a different approach as the first one, and I'm gonna show you. What we did is we thought, okay, let's be smart. We don't need to create 100 different pipelines, right? We can at least merge everything that we know from one system. So all the 3 shuttles that we have in this case for one system through one feature and inferencing pipeline. That was our idea. And before we start inference, we check for each of these shuttles, do we have a model available? If not, okay, then we can kick off a training pipeline and train a model, and we try again. That was our idea. Okay, it worked, right? It worked, that was great. Until there were more systems that we had to onboard, and we created more of these kind of pipelines. So it looks like this. It also worked, but it was a bit clunky. Why? Well, for example, when something unexpected happened, like a weird thing in the data and an error happened for one shuttle, it caused the rest of the pipeline to fail as well, affecting all the rest of that site. It was not really fault tolerant, and also the moment that we were growing and adding more and more pipelines, it also became a bit unmaintainable. It was hard to keep track of everything, and it was just 2 data scientists that couldn't manage everything. So we were actually constantly in firefighting mode. It was, yeah, it was not nice. We were thinking, okay, you know, it worked well for 3, but now that many more systems are being added, this is not the way to go. We need to have a new plan. That's why we set up some new requirements. Okay, we now knew that we wanted to scale it to multiple sites, We also wanted to make sure that there is some kind of data isolation for security reasons. For our users, we want to have the dashboards refreshed daily, so somehow the pipelines need to be run daily. We want the pipelines to be fault tolerant, so that they fix themselves and we can enjoy our coffee. And we need some built-in monitoring and alerting, such that we don't need to look at them every day, but we will get an alert whenever something goes wrong. And we can worry about other things and building and developing new models, what we're hired to do. So that brings us to hopefully a better version. And Azu, please enlighten the audience where we are at now.
Thanks, V. Okay, so let's look at our second attempt. Okay, so we start with the shuttles that are in the warehouse in a site. So for now, we will keep it for one site. And we get that data from the shuttles via Wi-Fi to the cloud. After that, it gets into our Databricks environment, where we have our pipelines working. And we have the first pipeline, which is our data ETL pipeline. And the first task is to make sure that we collect all the data that we need from the shuttle into our catalog. Once it's there, we do all the data pre-processing. So here, imagine data cleaning, future engineering, everything to make sure that it's ready for the next stage, which is the training part. So at the moment, we don't have any models, but we have another pipeline that has a task that starts with a training orchestrator. And this one, we will make sure that each of our shuttles, we have its own model. But we also need some model evaluation in place. So the second task will be to make sure that it gets evaluated and registered. And once they are ready for production, then we're ready for the next step. So new data is coming in from the shuttles. So it's getting processed every time. And when it's done, we can move to our inference pipeline. And our inference pipeline, again, has like another orchestrator, which its task is to make sure that for each of the shuttles that we have for that site, it collects the data that it needs, and it fetches the model in the inference task to create the inferences. And we have a final step, which we call aggregations. And here you can think that we don't show everything to the user, so we have some anomaly score in place and hourly data being aggregated. Okay, nice. So this is actually how the whole pipeline, all the pipelines look like. So at the end, we have the dashboard that Fee already mentioned. So we have our users looking at the dashboards every day. And the way it connects to our aggregations is through the back-end API that we have. Okay, but Fee mentioned that we had some requirements. So let's go and revisit them and see how we actually make them happen. So we cared about data isolation, so we don't want to leak data into another pipeline. So what we do for this site, each of these tasks has its own table. So we make sure that each site has its own tables and we don't mix around. But now if we want to scale up, instead of building a different pipeline, we just have a task running in parallel for the data ETL pipeline. And if another site comes in, then we just have another task running in parallel. But we do that for all the other steps as well. So in this way, we ensure that scalability is also easy for us. Okay, but we discussed fault tolerance. So how did we go about it? Well, here, since we have more granularity in our jobs, like we have some that are running at the shuttle level, then if something goes wrong with one of them, it won't interfere with the others. So the pipelines can still running even if one shuttle didn't have a model, for example. Okay, that's nice. What about data freshness? And here, for the ones that are familiar or are not familiar with Databricks, we use some of the tools. We leverage from the tools of Databricks. And specific for our data ETL pipeline and the aggregations, we use Spark declarative pipelines, which is just a framework to create data pipelines that are either streaming or in a batch fashion. And we schedule these every hour. Okay. for our more complex jobs, we use lake flow jobs. And these ones are just an automation workflow framework, also from Databricks, that help us to easily orchestrate complex tasks and schedule them. So for the inference, we run them every day as well. For the training, that one, at the moment, is something that we manually trigger. Okay, so yeah, we're almost finished with the requirements, but I would like to zoom in into the inference orchestration. Fee, can you explain the audience how it works?
Yes, just a bit high level. Let's dive a bit in the code just to see how it works, what we did. For this inference orchestrator, like Azu mentions, the functionality of this, that it just needs to keep track of all the shuttles that we have in the system, and for each system kick off a inference job, right? This is the whole key of our pipeline. For that, we just need to know where our inferences are stored. Okay, that's what we define in the init. Then we have a function that is actually triggering a job for a given shuttle, but it also checks whether a model exists. If a model doesn't exist, it will give us an alert, and we as data scientists know that we can create a manual trigger to train a model. So we have that a little bit under control. Then this actual infer assets is doing the triggering for all of the assets. So what it is doing, it is looking at all the shuttles that we have. For each shuttle, look at the latest prediction that we have available in that inference table, and then kicks off all the jobs with the given correct timestamp. And we do that in a parallelized fashion, and we just execute it. That's a bit high level how we do it. If you want to know the details, we can talk after. But once we have written the code, now we want to see it in action. As I said, we want to have it as little maintenance possible. So how do we deploy everything? Well, we have some amazing people in the team, one of them being a DevOpser. So he made sure that we can just worry about two things. We just need to make sure that our scripts are in some kind of project source repository, and we have all of our scripts ready there with some unit tests in there as well. And we need to worry about some GitOps configs where we tell what scripts depend on which and how we want to orchestrate that whole pipeline that we showed you. And with some DevOps magic, it all ends in Databricks. For the ones that are interested in the DevOps magic, just to show you the two flavors that we have some kind of fast lane build that with scripts just deploys the project source into Databricks, so we can quickly test end-to-end with data whether the functionality works end-to-end. And when we're really happy with it, we can then kick off our actual CI/CD pipeline with some testing, integration testing, and then it will package all the source code into wheel files and stores it in some kind of artifactory. And with some, and this is again to me magic, but with some Argo CD, Crossplane and Terraform, it will then deploy it to Databricks, and there our pipelines are visible. How does it then actually look like? Well, this is a screenshot of our Databricks, and I showed you the 3 sites that we have, and you can see now the inference orchestrator for each of the 3 sites separate. And if we would want to add a 4th site, we just need to change it in the GitOps configs, and a 4th one will pop up. So that is very little maintenance on our side. So we are happy we can enjoy the coffee with the new coffee machine that I have at home. Then, Azu, with a lot of these pipelines, how do we monitor?
Yes. Okay, so let's look one more requirement that we have. Do you remember? But before we deep dive into it, I want to go back to the expertise center that is looking at our dashboards every day, and they go and see that for one of our sites, we have 102 shuttles that are anomalous. So they come back to us to see what is happening. And we have a dashboard for all the models that we have, and we go to the ones that we have in production, Specifically, we filter by the site that we care about, and we see that some of these models are getting old, and our models do depend on seasonality. So it's time to retrain them. Okay, now we make sure that we have models that are working again, but also the pipelines need to be all the time working. Otherwise, our users won't have the data that they need in time. So we also have another monitoring to check the health of our jobs. And as you saw already, we have many jobs. So we have a dashboard where we can see all of the jobs that have succeeded and how long they took as well. Okay, and with that one, I think we finally checked the last item, right,
I
Fee?
agree. Yes. So we can go on holiday right now. I'm gonna pack my bags, right? See you next year.
well, not yet, because remember we mentioned that there was like some improvement, right? You can always aim for better. And so, yeah, we have some ideas for our future in the ecosystem that we have. We would like to be more efficient. So how can maybe we reduce the number of models by clustering smartly these models? Or, for example, the retraining. At the moment, it's being done manually, but how can we automate it? We know, for example, that temperatures and software updates will affect them. So maybe we can do something about it. But we also want to have a more robust pipeline. And we are missing centralized logs because we want to make sure that whenever an error happens, we can easily spot where it's happening and how and to fix it. And finally, we will also want to expand our testing framework. And finally, the quality. We are always aiming to keep improving the quality of our code, but also the efficiency, so it's performant enough. Okay, with that, yeah, it's been a long journey, right, Fee? And we have learned a lot during the way. We didn't have the perfect solution when we started. And yeah, we still are looking on how to improve. And if you ever find yourselves in this position, I hope you take some of our keys that we learned along the way. Just try to start small. Obviously, try to iterate and learn from the mistakes as much as you can. And each time, aim for better. And with that, we couldn't have done it alone, right, Fee?
No, just a very big shout out to the team because we couldn't have done it alone, indeed. And of course, we will keep continuing improving, like Asu said. I hope you have learned a lot from our journey from data scientists to accidentally becoming machine learning engineers. And yeah, all of that to hopefully that all your packages will be delivered on time.
We have 2 minutes for questions, but first, very much thank you for the talk. We're actually doing a competition with all the rooms who can have the loudest applause. Can I get one more round of applause? That's better.
Oh, thank you.
You get a PyData mug. So here you can drink your coffee as well, and you can remember this time.
Yes.
So we have 2 minutes, 1 minute for questions. Oh, damn.
Maybe two questions. Oh.
Yeah.
Hi, thank you for your presentation. Very informative. My question is about the retraining of the models. How do you know that it's because of seasonality, or did the model or the how do you call it, the shuttle needs maintenance actually?
Ooh, 2 questions in one, right? So when we have trained a model, how do we know when it's time to retrain? We are lucky that we are very close to our users and the sites. So I guess our retraining alert is mostly that we see in the dashboards and we hear from our users, hey, something is going wrong, and we think it's because of our software development. We need a retrain. So that is on our side lucky. If it's seasonality, we don't have anything automated yet. That's what we definitely want to improve. The other question was?
It's related. So it's related. Yeah. You think it's seasonality, but maybe the shuttle just needs maintenance. So maybe you are retraining on a bad shuttle.
Yeah, that is a good question. And what we see is like when it's due to seasonality, all of them start behaving anomalous and not only one or two. So that's when we see, okay, there is something external, not shuttle specific. So that's how we can tell.
Hopefully, none of them breaks down during seasonality change.
That's a good one.
That's a good one, yeah.
What we do see though is when we try to retrain them all, it always, the one that is really performing bad will pop up eventually, because you can always cross-reference due to statistic which one is really the bad one between them all. So that helps.
Yeah, sometimes like we can tell because it won't converge the model. So we know something weird is happening with that shuttle.
Unfortunately, that's all the time. I think hopefully you will be staying here for a
Yeah,
moment.
we'll have
So
time.
if you have questions,
ask
come
us.
here and ask V and Azu. And thanks again. See you in the next talk.
Thank you, everyone.
Thanks.